Welcome to another video from explainingthefuture.com. This time I'm going to talk about the future of artificial intelligence and robots. And specifically I thought I'd address two questions I'm always asked in this area, which are these. Firstly, what will be the impact of AI and robots on jobs, on future employment? And secondly, will AI and robots take over? Should we fear some future AI-robot revolutions as we see in science fiction? Now, to address these questions, we also have to think about a third question, which is this, which is, what are AI and robots? Because every time I start to talk about artificial intelligence, whether it's in a business presentation or here on YouTube, there'll be at least one person who will say, hang on a second, you're wrong here. Artificial intelligence doesn't exist, will never exist. What you're talking about isn't artificial intelligence at all. And so I thought we should get head-on into the issue of definitions. And this all started to be discussed way back in 1950 when Alan Turing, one of the great pioneers of early computing, proposed what he called an imitation game in this paper called Computing Machinery and Intelligence. And this is available online if you want to take a look. I'll give you a link in the video description. And in the imitation game, Alan Turing said, let's imagine we've got an interrogator and two human subjects in an experiment. And the job of the interrogator is to work out which of the human subjects is a man and which is a woman. And you can only do this by asking them questions over a text-based interface. Presumably you couldn't ask questions like, are you a man, are you a woman? Anyway, he'd be asking these questions over the text-based interface of these two human beings. But Alan Turing said, what would happen if you could replace one of the people, the subjects in the experiment, with a machine, with a computer? And if you could do that and the interrogator didn't know you'd replaced the person with a machine, you could deem that machine capable of thinking. And ever since that was proposed in this paper in 1950, the Turing test has been taken as a benchmark of artificial intelligence. If you can build a computer which can imitate a person in a text-based communication, you can deem it able to have artificial intelligence. Now, I have real problems with that definition of artificial intelligence. And I will go so far as to say, as I do here, measuring intelligence and measuring AI against human capabilities is both conceptually and pragmatically flawed. And we can start off in terms of thinking about this with the dolphin, because a dolphin is widely accepted to be the second most intelligent species on the planet. But a dolphin could not prove itself to be intelligent via the Turing test because it can't undertake a text-based communication with a human being. And it's not just me who has problems with the Turing test being a good measure of artificial intelligence. For example, if we look at Alan Turing's paper, in this paper on page 2, he has this quote here, where he's talking about the fact that if the man would try to pretend to be the machine, he would clearly make a very poor showing. He would be given away at once by slowness and inaccuracy in arithmetic. May not machines carry out something which ought to be described as thinking, but which is very different from what a man does? And I would say absolutely yes. Artificial intelligence doesn't have to be like human intelligence. We've got 7 billion plus human beings on the planet. Why do we want to make other forms of intelligence just like us? Surely we want to make something a bit different. So I would go back to the history of computing to give us a different perspective on what artificial intelligence really is. And what we've got here is a model called the 5 Ages of Computing from my book, Digital Genesis. I've talked about this model in several other videos, so I won't go through the detail of it here, but it basically gives us computing in phases across the decades. And I would suggest what this model reminds us is that early computing and personal computing, those ages of computing, were very much focused on computation, using a machine to do calculations. But over the past 20 years, the focus in terms of key value add and new things in computing has been on communication, linking things to things, people to things, and people to people using computers over electronic networks. But looking ahead, I think where we're going now as we go into the cognitive computing age, the age of artificial intelligence, the key focus is going to be on prediction, which means you can give a computer, a neural network running on a computer, you can give it some information and it can learn from that information, and then you can give it some new information it hasn't seen before, And based on its previous learning, it can infer something about the information you've given it. It can make a prediction based on it. Based on what I've been told before, what I've seen before, what I've learnt before, I think what you're showing me is actually an apple or a banana or a picture of the Eiffel Tower or whatever. That's what machine learning is all about, learning to predict probable outcomes from previous things that have been learnt. So, for example, if you want to have an autonomous vehicle, a car that can drive itself down the road, it's got to have very good vision recognition systems that can make accurate predictions of what it's looking at in order not to run people over and run into things like that. Now, we could get, as I've already implied here, into all sorts of deep debates about this, whether we can think about AI as purely being about prediction, or whether we have to think about comparisons with human beings and other forms of intelligence, and what is intelligence. There are some great debates to be had here, both technically and philosophically, about, can a machine ever learn? But I don't want to go there in this video. I want to get back to the pragmatics of artificial intelligence. Because right now, IBM, Google, Microsoft, Amazon, and others have already created and are starting to sell what they call AI, specifically cloud-based AI, cloud AI services. And they sell these bits of AI in little like Lego blocks that you can access over the internet. You access them using standard APIs, application programming interfaces, and you can put them into your existing systems to give them some form of artificial intelligence. And just to give you an idea what that means, let's go across to the internet. Here we are. Here we are on the IBM page for IBM Watson, which is their cloud AI service. As you can see, IBM Watson is AI for business. IBM call it AI. And if we look under products, we can see various products come up, hopefully in a second. There we are. Pre-built applications here. Things like, oh, look, it's scrolled all by itself. What's it doing? Don't you just love web pages that try to be too clever? Anyway, IBM Watson Assistant, Watson Discovery, Natural Language Understanding, Speech to Text, Text to Speech, Knowledge Studio, Language Translation, Language Classifiers, things to help with advertising, stuff like that. We go across to Google, we see the same thing, AI and machine learning products. If we scroll down here quite a bit, we get to the stuff. No, I just missed it, didn't I? There we are, conversational AI, speech to text, text to speech, again, virtual agent tools, natural language tools, etc. If we go across to Microsoft, we see the same thing. Again, if we scroll down in Azure Cognitive Services, we see we've got down here, look, speech-based services. You're getting used to this now, your language-based services, vision-based services, decision-based services, all bits of AI functionality you can access in the cloud, plug into existing business systems or build new business systems from. And we'll also look at across to Amazon. Amazon has machine learning on AWS, innovate faster with the most comprehensive set of AI and machine learning services. So as you can see, these companies are selling AI. And I remember a few years ago, I did a presentation to a large business audience all about AI. And I was on a stage with multiple people in a question session a bit later in the day. And we had some academics talking about the philosophy of AI. And we had over here the head of Amazon in the UK, and who was clearly selling AI, and he was despairing about the academic debates about the philosophy, as was I. I think we really have to move on and say AI exists, it's nowhere near as powerful as it's going to be, but we can see the direction of travel, the sort of services that are going to start to be transformative. So I'm going to stick here, as you would probably guess, to some pretty pragmatic definitions. I'm going to say that artificial intelligence refers to computing applications and services that can perform cognitive work. Or, in other words, AI applications and services enable mental automation. They allow things that used to take place inside the human head to take place in a machine. It's therefore quite straightforward to define a robot as a machine that enables physical automation. So basically, AI can automate things that go on in our heads, and robots can automate things that go on with our bodies. Although this said, as it says on the slide, robots are increasingly machines with embodied AI to control their physical selves. Because although the very early robots back in the early 1950s in car manufacturing plants were absolutely dumb, they were hydraulic machines capable of punching out things and putting things together and welding and stuff like that, these days, many robots have got some level of artificial intelligence added into the system, as I'm sure you would expect. So, let's think in that context about the rise of the robot. As I've just said, robots traditionally have been pretty dumb. And because of this, robots still today, you'll find in many business scenarios, in many factories, are working what they call a structured environment. They are separated out from people. So say in a car manufacturing plant, you won't get robots and people working side by side. The robots are often in cages, physically separated from people, because they might injure the people if the people get too close. The robot won't know they're there. It won't stop doing its welding or moving its arms around if the person's in the wrong place. So you have to have that separation. But what's going on today is we're starting to see more and more what are called autonomous mobile robots, AMRs. Robots that have got enough level of AI inside them or accessed from the cloud, might be internal, might be remote, but they've got access to some level of AI which allows them to make reasonable predictions about where people are and things are, and therefore robots can work alongside human beings in what we could term a semi-structured environment, which is more like typically a warehouse, maybe some types of healthcare scenarios, and then in time we'll see robots working in completely unstructured environments, like people's homes, where basically there's chaos. You can't possibly write the rules for the robot of where people might be and what they might do when you get to domestic scenarios. AMRs are already very common in warehouses. They weren't not much more than 5 years ago, but over the last 5 years we've had almost an unseen revolution. The level of robots that's gone into warehouses and other locations like that in recent years has been astounding. And a lot of it's been led by Amazon. Amazon's put over 100,000 AMRs into its fulfillment centers in the past few years, and it's now starting to sell them to other companies via a company called Amazon Robotics. As it says here, we'll soon start to see AMRs on our roads because an autonomous vehicle is effectively a robot, a physical machine controlled by AI. And I think alongside that, we'll start to see more and more use of robots in manufacturing, working more and more alongside people, and robots in things like retail and healthcare. To give you some idea of that, let's just briefly have a little nip out to the internet again. It's a marvelous thing. Here we have the website for Amazon Robotics. It worries me because this little search box appears, and however I scale the page, it goes across the letters Amazon Robotics. It's all about jobs, though. You can search for jobs in Amazon Robotics. 344 jobs going right now at Amazon Robotics. And you can see over here, this is what a lot of their AMRs look like. Little things that shuttle things around in their fulfillment centers, or increasingly in other people's fulfillment centers. And the other company I just want to point out to you, because it does some amazing stuff, is Agility Robotics. And they are developing an incredible robot for use, particularly in warehouses, to move things around. Or you can see it here, look, wandering along, having a little stroll as robots do in the morning, obviously going off to work, having a little walk. Maybe it'll do something else in a second. Oh yes, it's going towards its place of work. Anyway, I'll give you a link to Agility Robotics and Amazon Robotics in the video description. So, all of that gets us on to the question I said I'd address a little while ago about AI, robots and jobs. And really, this all comes back to the subject of automation, and in particular it comes back to the subject of to what extent can we substitute labour and capital, in other words, people and machines. Before the Industrial Revolution, the answer was not very much. Most things you wanted to get done had to be done by a person. And then we started to create machines that could do a lot of physical activities, not mental activities. And increasingly, as I've just been discussing, we're creating technology that can also do various mental activities. So what's really happening over time, as this diagram tries to capture, is that the opportunity to substitute labour or capital when you want to get something done, to use a machine or a person, that opportunity is getting bigger. The overlap of jobs that can be done by either is getting larger. And that isn't to suggest that all jobs will soon be done by machines, by AI and robots, but the possibility will exist. People, as employees, as workers, are increasingly going to be in competition with technology when a company is trying to work out how to complete a task. And I think the key word here is task, because there are all sorts of academic articles around that have been for years and years saying that X% of jobs are about to be automated in, say, 10 years' time. It's not difficult to find academic papers. I've got loads of them down here, all sorts of academic papers, and they tell you things like, in, say, 10 years, 20% of jobs will be automated, 30%, 40%. Depends where you are in the world how the figures go. It goes up to about 60% in some parts of the world if you believe all the studies. But all of the studies tend to focus on the fact that X percentage of jobs will be automated. Let's say it was 20%. I think that's a fundamentally flawed way to look at it, because actually we're not going to see AI and robots automating that many jobs. Why? Because a job is defined by a role profile, a set of tasks that has been designed to be done by a human being. So I think what's going to happen is a certain percentage of tasks in work are going to be automated, not jobs. And you might go, what's the difference? You're playing with semantics there. But I think it matters, because if you say, let's pick 20%. Let's say 20% of jobs are going to be automated by AI and robots in the next 10 years. You would basically say, this 20% of people have got a problem. Over here, this 80% of people will continue exactly as they are. I think that's the problem. That's not what's going to happen. Because if you say 20% of work tasks will be automated across the next 10 years, I think that's a reasonable prediction, or at least will be able to be automated. In that circumstance, those tasks will probably be spread across, 90% of jobs, 95% of jobs. Some jobs will have a few things that will be automated, some will have a lot. But it means you go from a world where you basically say 20% of people have a problem, 80% of people, the rest of us, people always put themselves in the 80%, we can just continue as they are. Whereas if you accept that most jobs will have some tasks inside them that will be automated in the next 10 years, this becomes an issue for all of us. There is, if you like, no escape. We all need to think about what bits of what we do, what we currently get paid for, are likely to be doable and may be done by robots and AI in the next 10 years. It is a scary thought. So you ask, what things are most likely to be automated? Well, it's not that difficult to answer this question. It is things that can be easily codified into standard steps, standard routines, and which are based on very, very clean data, very well-structured data. They're going to go first. Things like tax accounting, compliance, jobs where you're applying often rules written on the screen to information on another screen and ticking boxes, that sort of stuff, obviously machines are going to get better and better at doing. But more broadly, all tasks based on information processing and all tasks based upon digital human interaction are good candidates for AI automation. If what you do in your job is to communicate with someone via email or via phone or by video link, the chance of that being automated is much higher than if you communicate with people in your job face to face, or you deal with people much more directly. And of course, the pandemic is pushing more and more people to work and has pushed more people to work from home electronically, which in turn means more and more jobs will potentially be automatable. It's a very interesting dynamic going on there, which I haven't seen a lot of people talking about that. Some people in the future will find that if they've got really good digital skills, the skills we've all been told to get in the last 10, 20 years, they will become the least employable. Because ultimately, if you've got very good computer skills, you are capable of dealing with customers via email and doing everything remotely, and suddenly that's going to be the automatable bit. People say to me, how do you spot the people who are likely to have the tasks they're doing automated and the people who won't? And I always say, well, it's easy. Go to an event, which admittedly at the moment is difficult because of the pandemic. But if you go to an event where lots of people are arriving for something and there's hundreds of people in the room and they haven't met each other before, and you watch people go in, and I've done this a lot. I for years worked as a speaker, freelance. I was always arriving at places and meeting lots of new people. Two or three times a week I was walking into this room with hundreds of people I hadn't met. And in that circumstance, most people have one of two reactions I have observed. I've started watching this. The first reaction is people go, oh, lots of people. I'll go and try and talk to them. And the other reaction is, oh, lots of people, smartphone. And if you're one of the people who goes, lots of people, smartphone, I'll stand in the corner looking at my machine, you're probably one of the people who's going to find a lot of parts of their job are going to be automated. If you're one of the people who goes, people, I'll go and talk to them, you're probably less likely to be made redundant by robots and AI in the next 10 years. Think about that. Human interaction, human skills are going to be far more significant in the workplace than digital skills as AI and robots become more widely used in the workplace. Having said all this, I think we can get too negative. There are a lot of studies that I've said going, lots of things are going to be automated. But it's also the case that AI and robots will augment human occupations. They will allow us to stop doing the drudgerous part of a task and do more interesting things, higher quality of work, more exciting, more interesting work. To what extent will that happen is difficult to judge. And it's certainly the case if you look at the business press and the academic literature on this area. It's all written about people at very high-level jobs in management positions who are able to do exciting new things. It's not written about everybody else, if you see what I mean. And therefore, we have to be a bit sceptical. We do know across history that, by and large, new technologies have come along and people have feared they would take jobs. And in general, that's not been the case. It's been the case that new jobs have been created to replace the old jobs. People have worked in slightly different ways. And probably, to some extent, this will happen again. Certainly, there will be new roles. There was a very interesting paper written in 2017, the jobs that artificial intelligence will create. There's an exciting paper, and written by a guy called, James Wilson and his friends, and they suggested 3 new types of job would come into existence. First of all, trainers, people whose role will be to actually explain human beings to machines. Because you can easily create an AI these days using some of the tools IBM and others have available to get on with customer service roles and making decisions and all that kind of stuff. Except that human beings don't just do things on a logical, rational way. We understand tone and context and things, and machines often don't. There are already people paid to talk to IBM Watson in natural language so it can learn from them about the human world. There'll be a lot of this going on for a very long time. Some of us will end up being trainers for artificial intelligence. The other way around, there's going to be a lot of work, I think, I agree very much with Wilson and his colleagues in this, a lot of work for explainers, people whose job is going to be to explain to other people in the company why an AI did something. And that's difficult because neural networks are not using rules to make decisions. They are using inference, inferring from data they've learned from how they make a decision, but you can't necessarily just look inside the black box and see where the decision came from. But in companies, when you have things like audits, people sometimes want to know, and therefore people who can try and analyze how a machine made a decision and explain it to the rest of the people in the company, that'll be an interesting job. And finally, they talk about sustainers, basically people who oil the wheels, people who sort of fill the gap between the AI and robots getting on with things and the people working with them. Automation ethicists, people who try and explain to robots and people working with them how we deal with ethical issues in a company. People who are machine relations. These sort of job titles we never thought of before. I like this paper just because of the words it introduces. It's got lots of fantastic new job titles in here. We can think about how we'll integrate with machines in the workplace in the future. So that gets us to the question, will AI and robots take over? Will they be some horrific force in the future as they are in science fiction? Will AI and robots be like this? Will they start wearing earrings and chains and things like that? I don't know. I made this image this morning based on a 3D model I built years ago because I needed somebody for the video thumbnail, so I thought I'd put it here in the video. I don't think this is the future of AI and robots. What I do think, though, is we can answer the question about the extent that AI and robots will take over by thinking about digital transformation, which is the big trend in business which refers to how we can use digital technology to transform how businesses are working. And again, this is a slide I've used previously in other videos, and this is basically, for me anyway, the key technologies of digital transformation. The top 12 here are the ones we've got right now, which are already starting to transform all kinds of things in our lives. The bottom 4 are ones that are coming along, now the exciting future things. And I'm not going to go through all the things on this slide here. What I want to do, though, is to highlight the fact that effectively AI is critical to a very large quantity of these things. If we want to analyze big data, if we want to build the best augmented reality systems, to get the best value from the Internet of Things, to have autonomous vehicles and robots, and have what are called dark factories, factories where you turn the lights out because there's not many people left. If you want all those things to happen, and we might not, but if you do, AI has to be involved. And then the things here in the slightly darker red, things like virtual reality, cloud computing, they don't require AI, but they're very likely to use it to make them better. And things like synthetic biology, molecular self-assembly, quantum computing, organic computing, cybernetic interfaces, these things we can conceptualize, and humans can come up with designs to a level. We will need, though, AI to do the nitty-gritty working out of stuff, because our brains are simply not designed to handle intense mass complexity the way that artificial intelligence and a neural network can be designed to do. So the point I'm trying to make is I think that effectively AI and robots are set to become very heavily involved with many aspects of our lives, because they're going to be very heavily involved with many new areas of science and technology, which in turn will be involved with many new products and services. More broadly, I would make the point that the most fortunate people on the planet, those of us living in developed nations with the highest levels of wealth, we have got very, very used to relying on very sophisticated systems in our civilization. Systems for supplying everything from energy and water and food and transportation and entertainment, all these things pumped into our cities. Our cities would not keep going for more than 2 or 3 days without their basic services. So we've become very reliant on sophisticated systems. But as the pandemic, if nothing else, has shown us, these systems are also highly delicate. When they get out of balance, it goes wrong very, very rapidly. And for many years, the world has been pretty stable. But if you can see anything in the news today and across the past few years, it has been the world is less stable. People say to me the world's less predictable. I don't think that's true. I think the world is still pretty predictable, but the levels of change and complexity are going up and up and up. And because of that, it is very obvious now that very, very few human beings have the capability to manage well or manage at all the highly sophisticated systems, the highly delicate systems on which all of our civilization, pretty much all of our civilization, now depends. So if you ask me the question, do I fear a robot and AI takeover? My answer is very simple. No. What I fear is humans remaining in control. Because I think if humans remain in control, we're going to get into more and more problems. We have to let the technology we have created start to take a bit more control of the systems that keep us alive and keep us happy and keep us who we are. Because if we don't do that, the consequences will be dire. So I'm actually quite looking forward to a world where we have more things being run by AI and robots. Anyway, that is now it for this presentation. I hope I've given you lots of things to think about, to write about in the comments. We can have a great discussion there. But now that's it for another video. If you've enjoyed what you've seen here, please press that like button. If you haven't subscribed, please subscribe. And I hope to talk to you again very soon.